as floodwaters there are rising to dangerous levels.
Since late December 2022, Californians have been exposed to historic levels of rain and snow, which have flooded roads and homes, forced evacuations, and left millions without power. Almost the entire state received 400 to 600% of its typical average rainfall since Christmas. 9 atmospheric river storms, which are air corridors that can carry massive amounts of water thousands of miles, have caused cascading effects such as landslides, sinkholes, and downed trees, causing damage to roads and homes. The state has gone from one extreme to the other, from extreme drought and depleted reservoirs to excessive rain all at once. What caused this abrupt change from drought to deluge, and why are all these events happening now? Is North America on the verge of experiencing its worst natural disaster in decades? Stay with us until the end to find out the answers to all of these questions, because something terrifying is taking place in North America. Floods can surge all year round in every region of the world. However, determining whether or not a particular flood is related to climate change is not an easy task, according to the experts. This endeavour is made more challenging by the scarcity of historical records, particularly for the most severe floods, which occur infrequently. It can be tempting to blame all floods and other extreme events on global warming. However, weather is not the same as climate, even though weather can be affected by climate. For example, scientists are confident that climate change makes unusually hot days more common. They're not as sure that climate change is making tornadoes more severe. Flooding, like other natural disasters, is complicated by a number of competing factors that can influence its frequency and intensity in opposing ways. Climate change, which is aggravating extreme rainfall in many storms, is becoming an increasingly important factor. Precipitation, snowmelt, topography, and soil moisture are all important factors in flood development. Some factors may be more important than others depending on the type of flood. A river flood, also known as a fluvial flood, occurs when a river, stream, or lake overflows with water, usually a result of heavy rain or quickly melting snow. A coastal flood occurs when land areas near the coast are inundated by water, usually as a result of a severe storm colliding with high tides. Flooding can also occur in areas where there are no nearby bodies of water. Flash floods in particular can form anywhere there is heavy rainfall in a short period of time. And that is exactly what is happening in California. California has been battered by storm after storm, resulting in severe flooding that has claimed at least 19 lives and forced nearly 100,000 people to flee their homes. And there's no sign of the storms abating anytime soon. Floods are due to recurrent waves of atmospheric rivers that typically lead to high rainfall. These are not unusual for California, said Manu Lal, an engineering professor and director of the Columbia Water Center. Atmospheric rivers are concentrated streams of water vapor in the middle and lower levels of the atmosphere that are 100 to 250 miles wide. These sky rivers can transport massive amounts of often beneficial moisture. A handful of atmospheric rivers are responsible for 30 to 50% of annual precipitation on the West Coast. Extreme rainfall, however, can result in catastrophic flooding and mudslides. It can be overwhelming when they arrive in quick succession, as has been the case in recent weeks. Too much of a good thing for a drought-stricken state. Since December 20, weather patterns over the Pacific have revealed that the jet stream has been in a zonal pattern, flowing straight west to east, with a region of upper-level lower pressure to the north and an area of high pressure to the south, closer to Hawaii. Storms on this path tend to pick up warmer moisture as they race across the ocean one after the other. This is in stark contrast to the patterns that brought the Southland a wet December 2021, followed by a record dry January and February 2022. The upper-level high that was located in the North Pacific at the time of the La Niña event in December 2021 moved away to the west just the right amount, which made it possible for storms that originated in the Gulf of Alaska to travel down the west coast while passing over water. This upper high-pressure system has been blamed for preventing storms from reaching a parched Golden State, resulting in consecutive dry winters in California. Storms moving south over the ocean gather moisture, causing more rain. The high then shifted back to the east in January, slamming the storm door shut for Southern California, resulting in a record dry January and February, months that are normally the wettest in the state. Storms riding along the storm track were pushed inland over the Rockies or the Intermountain West. These are known as inside sliders. This pattern favours Santa Ana winds in Southern California, where wildfires erupted in February. When Super Bowl 56 was played at SoFi Stadium in Inglewood on February 13, the rain-stricken state had to contend with dry conditions and above-average warmth, prompting a heat advisory due to predicted highs of 85 to 90 degrees. Such climate patterns are more typical of La Niña, the cool phase of the El Niño Southern Oscillation, ENSO. Based on tropical Pacific Ocean and atmosphere conditions, this is the third consecutive winter that is firmly in La Niña territory. La Niña is expected to persist, with a 50-50 chance of conditions becoming neutral from January to March. Nonetheless, conditions in the state are drastically different this year compared to the previous two La Niña winters. The snowpack is currently twice average, with approximately 310 inches accumulating at Mammoth, which is more than any of the three previous seasons there. La Niña usually means warm, dry weather in Southern California and the Southwest, but this isn't always the case. Central California remains the primary focus of this El Niño-like jet stream position, as well as the region of the state with the most above-average precipitation. For reference, San Luis Obispo sits just north of 35 degrees north latitude, the line that the persistent, elongated Pacific jet stream has followed across the ocean in recent weeks. A bit to the south, the Santa Barbara area has received 12 to 15 inches of flooding rain. Even though California has been swamped with rain in recent weeks, it is insufficient to compensate for more than 2 decades of drought, which played a significant role in record-breaking fire seasons. When atmospheric river moisture plumes in the lower and middle levels of the atmosphere collide with mountains, they are forced to rise quickly, increasing rainfall. Because of this collision and lifting effect, mountains extract the most moisture from atmospheric rivers. This often results in mud and debris flows. Hillsides that have been blackened and deforested by fires are the absolute worst place for heavy rain to fall. And heavy rains at higher elevations require the water to go somewhere, and that somewhere is always downhill. Is climate change making these events more extreme? As humans continue to consume fossil fuels and heat the atmosphere, the warmer air can contain more moisture. This means that storms in many regions, including California, are more likely to be exceptionally wet and violent. Scientists are also investigating whether global warming is altering the way winds transport moisture around the atmosphere, perhaps influencing the frequency and duration of air rivers that sweep over California each year. They have not, however, reached solid conclusions on these issues. The dominant thing that's happening is just that in a warmer atmosphere, there's exponentially more potential for it to hold water vapor, said Daniel L. Swain, a climate scientist at the University of California, Los Angeles. And that exerts a really profound influence on things. In a study published last year, Dr. Swain and Xingyan Huan of the National Center for Atmospheric Research in Boulder, Colorado, projected that California today has a roughly 1 in 50 probability of suffering a storm of equal strength to 1861-62. They estimate that climate change has already increased those odds compared to a century ago. It's unknown how global warming is influencing the chance of atmospheric rivers crashing into California in rapid succession. Another study published last year found that half or more of all atmospheric rivers that hit the state between 1981 and 2019 were part of an atmospheric river family, or a quick procession of storms. Nonetheless, the enhanced capacity of the warmer atmosphere to hold moisture is reason enough for California officials to brace for more catastrophic rain events today and in the future. Given the magnitude of the disaster, damage assessments are ongoing and precise figures are not readily available. Reports of home damage, on the other hand, are emerging, painting a picture of devastation. Following this disaster, the presence of mud and debris in homes is a major health and safety concern, preventing people from returning home. Significant damage to roads, bridges, water facilities, public buildings, and equipment has been reported across the state. According to Monterey County officials, the storms caused at least $30 million in public infrastructure damage. Officials in Sonoma County estimate that the storm caused approximately $11 million in initial damage to local roads and other public infrastructure. According to Adam Smith, an applied climatologist and disaster expert with the National Oceanic and Atmospheric Administration, the state's costs could exceed $1 billion, making it the first billion-dollar disaster in the United States in 2023. Damage to public infrastructure, according to Smith, is an often overlooked cost associated with disasters. Damage to public infrastructure can have repercussions such as preventing access to isolated or rural communities. The heavy rain has produced dramatic images of sinkholes, which form when collected water weakens the ground beneath the surface, making it more prone to collapse. Flooding has cost US taxpayers more than $850 billion since 2000, and accounting for 2/3 of all natural disaster costs. Floods have inundated homes, cut off communities, and left financial and emotional scars across the country in both small towns and large cities. With rising global surface temperatures, there is a greater likelihood of more droughts and stronger storms. Every degree Fahrenheit increase in temperature can result in 4% more water vapor in the air, and because the average surface temperature was more than 2 degrees Fahrenheit higher in 2020 than it was a century ago, there could be nearly 9% more moisture in the air and clouds. Many natural landscape features that would otherwise slow rainwater's path across the land and absorb it deeply underground have been eliminated by our roads, sidewalks, buildings, shipping canals, dams, and agricultural practices. Because so many of these natural landscape elements have been lost as a result of development, both inland and along coastlines, more rainwater remains unchecked and unabsorbed at the surface, transforming life-giving rains into devastating floods like the one currently happening in California. Let us know what you think about these changing climate patterns in the comments section below.